Walaikum salam.
Okay, today we'll discuss how to identify the ions present in a salt. So basically this whole topic is about memorization. You have to learn these tests and observations. So how to identify the ions present in the salt? Actually, salt contain two ions. The salt contain positive and negative ions. So there is a separate test for positive ion. So there is a test for positive ion and there is a test for negative ion. So you have to learn these tests, positive ions, because in electrolysis, the positive ions move towards cathode. That's why positive ions are known as cations. So we can also say test for cations. Cation here refers to a positive ion. And because negative ions are attracted towards anode in electrolysis, so that's also known as test for anions. You have to learn or memorize this table, the test for the cation and the test for anions. How we test, first we'll discuss how we test a positive ion, and then we'll discuss how we will test a negative ion. So example, if you want to test a positive ion, so there are two ways to test a positive ion. The first method to test a positive ion, what you can do, you can see here, this is a test for positive ion or cation. What you can do or what you can add aqueous sodium hydroxide, means NaOH. And it can be two ways. First, you can add 5 drops, small amount, and then you add excess. Excess means more than enough. So what happens if a salt contain aluminium? If the ion present in the salt is aluminium, and you add 5 drops of sodium hydroxide, so what it will give? So if the positive ion is sodium, because the salt contain positive and negative ion. If positive ion is aluminium, example, if there is an aluminium ion present in the salt, and what you did, you add sodium hydroxide. So when you add this sodium hydroxide, because there will be aluminium, a salt is there, salt contain positive and negative ion. So there is a positive ion aluminium and negative ion we don't know. Example, Y is a negative ion. So what happened? The sodium will take position of aluminium and aluminium will take position of sodium here. So what it will form? It will form aluminium hydroxide plus sodium, and that the negative ion is Y. So what is this aluminium hydroxide? When aluminium hydroxide is formed, what is the appearance of this aluminium hydroxide? Aluminium hydroxide is white in color. So if you have a white solid, that's why you will say, you will observe white PPT or white precipitate. So this is a test for the positive ion. Different positive ions have the similar test, but results are. So example, you have a salt. I'll repeat. Example, if you have aluminum salt. So if you have aluminum salt, what does it mean? Means it contains aluminum. And there is another element, any other element is there, we don't know. Say example X, or it can be Y. Any other element is there. So you want to show the presence of aluminum. So how you show the presence of aluminum? What you will add? You will add sodium hydroxide, NaOH. So when you add sodium hydroxide, sodium will take possession of aluminum and aluminum will take possession of sodium. So what will be the result? The result will be aluminum hydroxide plus sodium, and that element Y will be there. It can be any element. That's why I'm not using a specific symbol for that element. It can be any element. Y here means any element can be there, because this is a test for positive ion. So Y can be any element because this is a test for positive ion. We want to identify which positive ion is there. So element Y can be any element. It can be nitrate, it can be sulfate, it can be chloride, it can be sulfite. Any element can be there, or compound can be there, or molecular ion can be there. So Y is not an important here, because what we want to test the positive ion. So if we want to test the positive ion, we will add sodium hydroxide. When we add sodium hydroxide, sodium will take position of aluminum and aluminum will take position of sodium. So what it result? It will result in a formation of aluminum hydroxide and sodium, and that other substance is there, Y. What is this aluminum hydroxide? What is the appearance of this aluminum hydroxide? This aluminum hydroxide is a white solid. So if it's a white solid, so you can say you will observe white PPT or white precipitate. Is it clear? So if we want to test a salt that contain aluminum, so you have a salt solution which contain aluminum ion. So what you will do, you will add sodium hydroxide. So the moment you add sodium hydroxide, what you will observe white precipitate, a white solid will form, and that white solid is basically aluminum hydroxide. Is it clear? Then if you add an excess means more than enough. The positive ion, aluminum is a positive ion. You can see a salt of aluminum means it contains aluminum. Aluminum is a positive ion. And any other element, any other molecular ion can be there, that is negative. So I want to test this aluminum. So if I want to check or show the presence of aluminum, what I can do, I can add sodium hydroxide, NaOH. So when I add sodium hydroxide, the sodium hydroxide react with aluminum salt. It will result in a formation of aluminum hydroxide, which is white in color. So I can identify that this salt contain aluminum, or I can show this salt contain aluminum. Then if you add an excess, if you add excess of sodium hydroxide means more than enough. So what you will observe the precipitate dissolve and it will form a colorless solution. So what does it mean? Like you have, originally you was having a salt of aluminum. When you add sodium hydroxide, this result in a formation of white solid. This is a white solid which is aluminum hydroxide. But if I add an excess of sodium hydroxide, the term excess means more than enough or too much. So now we continuously adding sodium hydroxide. So what is the observation for us? We will observe that this white solid will dissolve completely, and it will make a clear solution or a colorless solution. So solution will turn clear or it will be colorless solution. So here you have to learn, when we add sodium hydroxide with aluminum, it will give white precipitate. If you add excess means more than enough. So if you have excess of sodium hydroxide, what you will observe? You will observe the precipitate of aluminum hydroxide will dissolve, and what it will give? It will give a clear solution or a colorless solution. Means it does not have any solid, because all of the solid dissolve in excess or too much sodium hydroxide. So for this one, you have to memorize, you have to learn these tests. You can see here this table. If a salt, if a salt contain aluminum and I add 5 drops of sodium hydroxide, so what I will get? I will get white precipitate. And if I add excess of sodium hydroxide, means if I add too much sodium hydroxide, what I will observe? I'll observe the precipitate dissolve and it form a colorless solution. Same thing, if the lead salt is there, means the salt contain lead. You have a container and this container is having lead ion. A solution is there of salt which contain lead ion. Any other ion can be there, but it is lead ion. And what you are doing? You are adding sodium hydroxide. So when you add sodium hydroxide and there is a lead ion, what will be the result? It will form lead hydroxide. And as it will form lead hydroxide, what is the appearance of lead hydroxide? It is also white in color. So what you will observe? You will observe a white solid will form in the solution. And if you add an excess, means more than enough or too much sodium hydroxide, what is the observation? If you add too much or more than enough sodium hydroxide, this precipitate will dissolve and it will form a colorless solution. Means the precipitate completely will dissolve and the solution will be colorless. Same thing, you have a zinc. Zinc is positive ion. So if a solution contains a zinc, if a solution contains zinc, so what you will observe? If you add sodium hydroxide or NaOH, so again this will also form white precipitate. And what is these white precipitate? These white precipitates are due to zinc hydroxide. And when you add an excess, when you add more than enough, so what is the observation? You will again observe that the precipitate will dissolve and it will form a colorless solution. If you have calcium, a salt contain calcium, and you add sodium hydroxide, what is the observation? It will form white precipitates, white solid, and in excess, the precipitate does not dissolve or it will remain as same. Like example, you have a salt, a container, which is having a calcium salt. So means calcium, the positive ion is calcium. So there is a calcium ion. Now what you are doing, you add sodium hydroxide, NaOH. So when you add sodium hydroxide to this salt which contain calcium ion, as a result, what you will observe, because calcium ion displaces, so like double displacement, calcium will take position of sodium and sodium will take position of calcium. So what will be the result? The result will be calcium hydroxide. And what is calcium hydroxide? Calcium hydroxide is also a white solid. So what you will observe? You will observe that there is a white solid formed in the solution. But if you add excess, excess means more than enough or too much. So when you add excess of sodium hydroxide or too much sodium hydroxide, what you will observe? You will observe the precipitate does not dissolve. So means it will remain white precipitate and it does not dissolve. Same thing, if you have copper ion in the solution, if a solution contain copper ion. So these are the tests which you have to learn or memorize. So if a solution contain a copper ion, so copper is +2. And what you're adding? Again, you're adding sodium hydroxide, NaOH. So when you add NaOH and the solution contain copper ion, what will be the result of this? This will result in a formation of copper hydroxide. So means the solution will form copper hydroxide. And what is copper hydroxide? Copper hydroxide is actually blue in color. So it will be blue solid formed in the solution. And this solid, whenever a solid is formed in the solution, what we use the term, we use a specific term for this solid. We call this as PPT, or we can say precipitate. So it will form blue precipitate. And in excess means if I continuously adding, or if I add too much, what will happen? In excess of sodium hydroxide, the precipitate will not dissolve. Why you are doing this? Because you have to learn the test for the ions. Why we do this? We do this to identify which positive ion is present in the solution. So using this technique, you can identify what is the positive ion present in the solution. Same way, if a solution contain iron 2, and you add sodium hydroxide, what it result? It will result in a formation of iron 2 hydroxide. And what is the observation when iron 2 hydroxide is formed? This will be how you will know that in excess it will dissolve. Actually, you have to memorize this table. You have to learn this table. There is a reason why some of the hydroxide dissolve in excess and why some of them does not dissolve in excess. But that reason is not important here. That's why you have to learn this table, memorize. I will give an example how you will use this table to solve questions. Look, in this question, this is how the exam they ask the question. a mixture of two calcium compounds are there. So there are two compounds C and D. And both of them are calcium compound, means compound C contain calcium, but we don't know what else is there with calcium. And compound D also contain calcium, but we don't know what else is there with calcium. Now what we are doing, to the first portion, we add aqueous sodium hydroxide little at a time, means a small amount. So if a salt contain calcium, and we are adding sodium hydroxide, so what will be the observation?
White precipitate forms.
So you can see here, a salt, they already mentioned in the question, a salt contain calcium, and what you will observe, you will observe white precipitate. So what you will write here in this one, to the first portion we add drops of sodium hydroxide little at a time. Little at a time means small amount. So if we add small amount, and already they mention in the question that this salt contain calcium, there was a calcium ion. These are the calcium compounds, C and D. So if we have calcium compound and we add sodium hydroxide, so what will be the observation for us? We will observe white PPT or white precipitate. Why there are 2 marks for this? 1 mark is for mentioning white and 1 mark is for mentioning PPT or precipitate. Or you can mention a white solid form, but you don't have to write the formula here. You just have to mention the white solid form. Excess of sodium hydroxide is added. Means this is a calcium compound. There's a calcium ion is there, and we add excess of sodium hydroxide. So if we add excess of sodium hydroxide and we have a calcium compound, so what will be the observation here? You can see if we add excess, the precipitate does not dissolve, or precipitate will be insoluble.
Well, there is no observation, right, sir?
Yeah, no visible change or no observation. It is mentioned in the question in the beginning. You can see they mention in the question these compound are calcium compound. You can see here the mixture of two calcium compounds. So C is a calcium also, and D is also a calcium. So means this is a calcium compound they mentioned in the beginning. And to a calcium compound, if we add sodium hydroxide, what is the observation? It will be white PPT. And if we add an excess, what we can write? We can write no visible change or precipitate does not dissolve. Same way, you can see here, in this question, a mixture of two compounds B and C. Compound B is a water soluble zinc salt. So compound B contain zinc, and compound C is insoluble. They did not mention what is compound C, but they mentioned compound B is a zinc salt. So there is zinc, and anything else can be there with zinc, zinc sulfate, zinc carbonate, zinc chloride, zinc nitrate, but we don't know. What we have to do, we have to test, we have to write the observation according to the test. Test on filtrate. So what will be filtrate here? You can see in the question they mention compound B is a water soluble, means it dissolve, and compound C is insoluble. So when you filter the solution, what is left on the filter paper is called residue. And what passes through the filter paper is known as filtrate. So which substance will be filtrate, B or C?
B.
B will be filtrate because B is a water soluble. So B will be filtrate here. And B already they mentioned what is B? B is a zinc salt. So means there is a zinc, and anything else is there with zinc. We don't know, but it is a zinc salt. Now what we are doing, so as we know that B is a zinc salt, so there is zinc and any other thing is there. we add drops of sodium hydroxide. If we add sodium hydroxide and there's a zinc salt, what we'll observe? If there's a
A white precipitate.
zinc salt and we are adding drops, so what we'll observe? We'll observe white PPT. So you can write here, you will mention here white precipitate. And for second, what we did, we are adding excess of sodium hydroxide, more than enough for sodium hydroxide. If we add too much sodium hydroxide and it's a zinc salt, what we will observe?
The precipitate dissolves to form a colorless solution.
So precipitate dissolve and it will form a colorless solution. So what you will write here? You will write here the PPT or precipitate dissolve, or the white PPT dissolve, and form colorless solution. Is it clear the idea how the question will be there in exam to identify these ions? Another example I will give. Two different solid T and V were analyzed. T is a calcium salt. Means it is a calcium, but what else with the calcium we don't know. So what we did to the second portion, T is a calcium salt. To the second portion, we add excess of sodium hydroxide. What we will observe if we add too much sodium hydroxide?
A white precipitate forms which doesn't dissolve in excess of sodium hydroxide.
Yeah, so white precipitate will form and it does not dissolve in excess of sodium hydroxide. So look, whenever in a question, it's a calcium salt. So when they mention it's a calcium salt, it means the positive ion is calcium and there's a negative ion will be there. There's no other positive ion. So one is calcium, then other ion will be a negative ion. And there is a test for negative ion as well, that also you will learn today. Is it clear till now? The idea that how you will use, so basically this table you have to memorize, you have to learn this table. So this is one of the tests for positive ion. You can add sodium hydroxide. There is also another test for positive ion, that's called aqueous ammonia or ammonia solution. So what is this test? This is also a test for positive ion. This is first test for positive ion. Either you can test with sodium hydroxide or you can also test with aqueous ammonia. This is a second way of testing the positive ion. You can either test with sodium hydroxide or you can test with aqueous ammonia or ammonium hydroxide. If there is an aluminum ion, if we add aqueous ammonium hydroxide or aqueous ammonia solution, what we'll observe? We'll observe white precipitate, but this time the precipitate does not dissolve. If it's a lead ion, it will also form white precipitate. Precipitate does not dissolve. If it's a zinc ion, it will form white precipitate. Precipitate dissolve to form a colorless solution. With calcium, there is no visible change, no reaction with calcium. With copper, it will form a blue precipitate and blue precipitate will dissolve and it will form a dark blue solution. Reason why I change the color here, it means this part is different from the previous one. That's why this I use a different color. You can see here, when you are adding aluminum, when you are adding sodium hydroxide, and if it was aluminum ion, it was giving white precipitate and the precipitate dissolve. With sodium hydroxide, you can see precipitate dissolve. But here with aqueous ammonia, the precipitate does not dissolve. That's why I use a different color to distinguish So what happened when you add aqueous ammonia? The same way it reacts. You have a solution which contain, example, aluminium ion. And you add aqueous ammonia. Aqueous ammonia or ammonium hydroxide, you are adding NH4OH. So moment you add, what will happen? Aluminium will react. Aluminium will displace ammonium and ammonium will take position of aluminium. So what it result? This will result in a formation of aluminium hydroxide. And what is this aluminium hydroxide? This aluminium hydroxide is white PPT. So you will observe white solid form. This is when you are adding 5 drops of aqueous ammonia. But when you add excess, excess means if I add more than enough or too much of aqueous ammonia or ammonium hydroxide. So what is the observation? What we'll observe? The precipitate does not dissolve or it will remain same as it was original. So aluminium, white precipitate, precipitate does not. Yes, you have to memorize all these tests for aqueous ammonia as well and with sodium hydroxide as well. So I will give an example. You can see the similar question I will discuss with you. Look, the same question. Two different solid T and V. T is a calcium salt. So means we know T is contain calcium and any other substance is there with calcium. So to the third portion, it contained calcium is there and any other substance. To the third portion was added excess of aqueous ammonia. If you add aqueous ammonia to a calcium salt, what is the observation? If you add excess of aqueous ammonia to a calcium salt, what is the observation?
No
Nothing,
reaction.
no precipitate.
Yeah, no precipitate, no reaction, no visible change. So no reaction is, if you write no change for precipitate, that's not acceptable. With calcium, you should mention because it does not react even. So if it does not react, there is no precipitate. So no precipitate, no visible change, no reaction. But you cannot say precipitate does not dissolve because with calcium, it does not give any precipitate with aqueous ammonia. Another question. Two solid S and V were analyzed. S is copper oxide. Okay. So there's copper and oxygen. So they give you the hint. The whole compound name is given to you. It's copper oxide. So this is copper oxide. And when you add sulfuric acid, it will turn into copper sulfate. But means the idea is that it contain a copper ion. Now it contain a copper ion. To the first solution, we add excess of sodium hydroxide. If I add too much sodium hydroxide, what will be the observation? If I add too much sodium hydroxide to a solution which contain copper,
A blue precipitate forms which doesn't dissolve in excess.
so blue precipitate will form and it does not dissolve in excess. Because normally when it, even when we say excess is added, but the thing is how you will add an excess. First you have to add some, like you're continuously adding it. So when you're continuously adding it, so what you will observe, first a blue precipitate, and when you add in excess, the precipitate will dissolve and it will form a colorless. Precipitate does not dissolve in excess. So the answer for this one, when you write, you will mention, because we add an excess, so blue precipitates does not dissolve in excess. To the second portion of a solution, we add ammonia solution. 1 cm cube means a small amount. 1 cm cube is like drops. So 1 cm cube is small amount or drops. So if we have copper, and already we know this is a copper ion there in the solution. The copper is there. So what is the observation if the solution contain a copper ion?
Blue precipitate forms, which
So
dissolves later on in excess.
So what happened? You can see here, we are adding a small amount. So if we add a small amount, so what we'll observe? We'll observe blue PPT or blue precipitate, and excess down you can see excess is written. So excess means more than enough. So if it's more than enough, what we'll observe? The blue PPT or blue precipitate dissolve and form
Deep blue color solution.
deep blue solution. This is having mark that when you mention deep blue solution, you have to mention that inky blue means royal blue, dark or deep blue solution, both are acceptable. Is it clear the idea till now?
Yes, sir.
Same way. So basically, it's totally about your memorization. When you memorize this table, you don't find this question as difficult, because if you directly recognize what could be the result, so you just have to write the result here. Solid E is aluminum salt. Aluminum salt means it contains aluminum. Solid E is dissolved and solution is divided into 4 test tubes. To the first test tube, we add drops of sodium hydroxide. If I add drops of sodium hydroxide and I have aluminum salt, what is the observation?
A white precipitate
So you can see
forms.
when I add, it will form white precipitate. So first answer will be white PPT. Excess of sodium hydroxide. I add more than enough sodium hydroxide.
Which
So what,
later on dissolve to form a colorless solution.
so what we'll observe, we add more than enough sodium hydroxide. So we'll observe the white PPT dissolve and it will form colorless solution. Then they mention test 1 was repeated using aqueous ammonia, like we are using it aqueous ammonia instead of sodium hydroxide. So if I use the same result, aqueous ammonia instead of sodium hydroxide, what is the observation with aluminum? White precipitate with 5 drops, and in excess the precipitate does not dissolve. So when I write here, I will mention it will be white PPT does not dissolve in, sorry, white PPT, yeah, does not dissolve in excess of ammonia solution. So, or you can also mention precipitate does not dissolve in excess. That's also right. You don't have to write the formula. You just have to write the observation, means what you will see or what you will observe. Is it clear the test for the positive ion? So there are 2 ways we can test the positive ion. The first one by adding sodium hydroxide. The second one is by adding aqueous ammonia. And you have to memorize these tests, learn these tests, so that you can identify or recognize the observation for specific salt. Next session, we'll discuss how to test the negative ion. This is testing the positive ion because the salt contains positive and negative. So this one is a test for positive ion. The second session, we'll discuss how we can test a negative ion. Any question related to this part?